All right, so when is this assignment due? Midnight. So, Bryce, could I talk about yours since I looked at your code?
Yeah.
Is that all right? Okay. So I looked at Bryce's code, and I don't know if this is a common mistake or not. Right. So we talked about how to do the stack, and we talked about doing it in an array-based way. And so I noticed that he happened to be still doing it in an array-based way. So I just wanted to be sort of clear on the assignment that what you need to have is you need to have basically a linked list for your stack, right? Does everybody get that, right? So we're having pointers to the next things in the list. And then I know Josh emailed me too about issues that he was having. So if you think of the stack as the top will point to the first thing on the list, when you go to push something on there, right, what you're doing is you're taking a new element, right, and you're making top point to it, and it will point to the old top. Now you got to do this order of operations right, otherwise it's sort of not going to work, right? So if you accidentally do it the opposite way, all of a sudden you only have one thing on your stack, or it points to itself, or right, bad things happen.
It just keeps printing the same thing.
It keeps printing the same thing. So that means that basically you copied the data in the backwards way. So if you set top to point to this, and then this is next to point to top, right? Well, now it's just going to point to itself, right? So that's the kind of the way that we don't want to design it. Yes.
Can you talk about why? However, you said we have to dereference the pointer. Why do we have to do it that way? Because I see like
is it the pointer to the pointer thing?
Yeah.
Okay, so yeah, we can talk about that one. I really haven't. Quit and upgrade. Sounds great. Let me grab the email that I sent.
Hey Spencer, you turned in your homework.
I did. So don't.
He's a little slow on turning in things. Takes his time.
Sorry about that.
I wanted to see the reply here. All right, so basically Josh was trying to do what? Asterisk, sort of equivalent to asterisk P for the pointer, arrow, and then something that was inside of that structure, right? So the problem was that it was giving you a warning, is that correct? I believe
it was giving me basically saying.
It let it compile, right?
No.
It didn't let it.
You're trying to access something that's not in the structure. Or
Yeah.
Okay. So what happens is one of the things that I tend to sort of avoid when possible is relying on what we call the order of operations. So what happens is as the computer is going through an expression, right, there are certain operations that we say have higher precedence than others. So if you look at mathematics, if you have, A plus B times C, right, you do the multiplication first, right, and then you do addition, unless parentheses are put in such that, right, you do them in a different way. And so when you do the asterisk arrow and then the value the attribute that you're trying to access, what happens is that arrow is going to actually bind tighter than the asterisk. And so it's going to try and do the arrow first and then try and do the dereferencing of that. And so what you have to do is you have to say, take that pointer to a pointer and dereference it at one level. So now it's just a pointer, and then use arrow to access that thing. And in this example, they show there are two ways you could do this, right? We really haven't gotten into the asterisk, right? But that's one way to do it, right? So that keeps dereferencing, and then you can use dot, which is the other way, right? So we either use arrow or we can use asterisk dot. Does that make sense, or should I do an example? Could I do an example? Yes, I can do an example.
The pointer to a pointer is just the address, right? Of the pointer.
Yeah. So, lots of questions.
Yeah.
Right, so if we have top, and top points to something, right? So this is a pointer to a thing, we'll call it. So if I want to change what that pointer to the thing points to, I need to get a pointer that points to that pointer so that I can modify it. So let me see if I can think of a good analogy. If there was an app, I don't know if there probably is, I'm guessing there is some app. Right, so if there was an app that would allow you to have an address that was on your phone, right? It has my address. You know, I live on Evergreen, right? So it has my Evergreen address written on it, right? If you can take that and copy it all you want, right? So that you know where my address is. But if I want to change that address, I might have to have an app that allows me to get into your app, right, that allows me to change the address there, not changing the copy that you printed off on a piece of paper or that you emailed to somebody, right? So we have to get the address of the pointer so we can change that original pointer so it points to the correct location. So, because if I change the copy, right, you're just changing the copy and you're not changing the original. So I need to get a pointer to that original so that I can change it properly. And so when we're going to do the push, and we'll do the example showing the binding, but when we're going to do a push, right, what we basically want to do is every time we want to add to the same side of the list, and it's probably easiest to always add to the beginning. Now you could add to the end and keep another pointer that says, where is the end? So when you do a pop, well, then that doesn't work, right, because then you want to go back one, and I think Josh ran into this, right? You'd have to reiterate through the list to find the one that was right before the one that was at the end. Right? So it's probably easiest if you do this so that the top of your stack is at the beginning of the list, right? And you're always changing that pointer to a pointer. So let's try and do an example. So I think that will help maybe explain some of these issues.
I'm sorry. I'm still getting it's still printing the same thing. I'm trying to find it over here.
You said like it was.
Like I was responding to you. I wasn't.
Yeah.
I'm sorry.
One of these days we'll talk about makefiles and it'll make some of our lives easier. So pointer. Okay, so I allocate a buffer. Let's do a scanf and read in some data. So I read in my data. Oh, let's make another thing called add. So let's say that I wanted to, in my add function, I'm going to add some data maybe to the beginning of the string. All right, so I'll allocate a new buffer, concatenate, my old string with some new data, and then print it off. So I want to actually modify what that pointer points to. So here, let's print it off. We'll print off this. So lots of string functions. So I'm going to allocate a new one. So char pointer foo equals malloc. I'm being kind of fast and loose with my buffers here, but and there's problems with that. But so let's see if I can remember. Let's see, stir copy. So I'm going to copy some data into foo. Well, let's look at stir cat.
You have regular colons instead of semicolons on 7 and
I don't know what you are talking about. These clearly look like semicolons. Okay, so we're going to use a couple functions. One is stir copy, so we can copy data from one string to another. So let me do a stir copy. Destination foo. What could I add at the beginning? I'll add some $signs, right? And then I can use stir cat. So concatenate two strings. So let me. So I need to, in this example, I would want to get the value. Right, so I'm not accessing the structure, so I don't have the, I don't have the type binding. Oh. Let's see. Well, we'll do this example. Maybe I can integrate a structure here too. Okay, so why do I need the asterisk in front of the C? Okay, so asterisk dereferences a pointer. So what does stir cat take? It takes two
Pointers.
specifically to what type of pointers? Char pointers, and what type is C? Char pointer, right? So I have a pointer to a pointer, right? So if I want to get the data at that pointer, right? So if we think of it as a drawing, right? So at some place I have some characters, right? Hi, right? And then in my main function, I have a pointer to those characters, and then I have a pointer that points to the pointer that points to those characters. Okay? And I need that pointer to the pointer so that way I can modify. So I have just created something that has $sign hi as a bunch of characters, and that's in some other buffer. And I have a pointer to that, and that is foo. And basically, since I have a pointer that points to this pointer, I can change it so now that pointer points to this pointer. So it can point to the right thing. Because if I have a copy, I can take the copy and say, oh, the copy points to here, but that doesn't change the original, which points to there. I know this is complicated, but, you know, it's the way it is. Does that make sense?
So basically, you're trying to change the value of the original string in the main function.
Yeah, so I'm going to change the value in the main function, right? So here I'm going to actually say C is equal to C is equal to the address of foo. Should change it. Let's see if it works. Spencer, did I make any more mistakes?
I haven't seen
I did forget.
You need to import the string library to use string copy and cat.
I might need to import the string library. Actually, probably give me a warning saying, we think you forgot something, but we're pretty sure we got it.
So you can screw up if you just include all, right? Have a wild card.
I don't know if it does wildcard includes.
Okay.
I know Java does, but oh, so I tried to give it x, right? I need the address of x, so I need a pointer to the pointer. So let's see if does that fix our stuff. Hey. And we failed.
Hey, this is the problem I'm having.
This is the problem you're having? Let me print off through here. Make sure I did that right. See, I think. Let's see. There we go. I forgot a new line in here, but what happened to what? I don't know. So I made sure my cat works, and then so I want to get the value at that location. So that gives me that actual location, right? So I had an address of my pointer to my pointer. So I needed to say that the value of this, right? So if I take one level, the char pointer becomes not just the char pointer becomes a char pointer, right? Because I'm dereferencing at one level, and I'm saying that is going to be equal to the foo, which was a different allocation, right? So it points to a different location in memory, so now I've modified my pointer so that it points to the right location. So again, I mean, this stuff is a pain, but so let's try and do the structure one, and let's see if we can do that one. So anybody, how do I define a structure? Let's do type def, right? Struct Bob. Right? And then I define the fields within my structure. So let's say int x, Bob is x and y, because that's pretty simple. All right, so Bob, pointer. Changing Bob. So I think what we were trying to do is we're trying to access, right, let's say we print off what x is, and then we change it to something else, right? So if we want to print it off, we would want to say, well, right? Typically you want to say this, right? B arrow X. Because normally you say B arrow X, but I need to dereference the pointer to the pointer, and so I say asterisk B arrow X. So I believe this is going to give me the same error that, let me define Bob here, I forgot my prototype. And then I pass the wrong type in here. I need the address of Bob. All right, so Bob is a pointer, and I need a pointer to the pointer. So now I get the error. So yeah, it is an error. All right, so because it's doing the binding of the arrow first, right? So arrow has a higher precedence. So it's going to try and do arrow first and then dereference that. So we could either totally dereference and then use the dot operator. So there are two valid solutions to this. One is to say, okay, so if I have a pointer to a pointer, if I dereference that, I have a pointer. And then if I dereference that again, I now just have the regular item, and then to access is the normal Java way. And you can say dot x, right? Or if we just do the dereference once, so I grab the value of the pointer, and then I do arrow. So I use parentheses to say I need to grab the value of the pointer first, and then use the arrow operator on that to dereference a pointer to a structure. So now if I comment on all these, right? Right, both of those are valid solutions to that. Yes, Josh.
So what if anything in your Bob structure, what if those are pointers? Like if it was in pointer X, how would you reference those?
Then you'd have to have another dereference. So let's suppose that y, I'll leave x how it is, but let's go with y is now a int pointer. So now I've allocated Bob, and so now I have to allocate space for where x or where y really goes. So I need to say Bob arrow y is equal to malloc. Let's say it is 10 times the size. So it can hold 10, right? 10 integers. It's an array of 10 integers. So now if I want to access that, now I would have to do another dereference. Right? So this would give me the first element that would be in that array. So you could either do it this way or, right, probably the easier way for all of us, right? Because now if you did that, you would have to do like pointer arithmetic, which would be not fun. Right, so we could get the first thing in the array or the seventh thing in the array, right? So array is another way to dereference a pointer to an array. So there's another dereference in there that you have to add. So every time you add another pointer, right? So it could be that y was an int pointer pointer. A pointer to an array of pointers pointing to integers, right?
So you'd have another.
Then you'd have another asterisk, right?
That would just be outside of the using those parentheses, or.
Yep. Right. So yeah, it becomes very difficult. So there was a method that the professor that I had at Kansas State used. He called it like the circle, where you start on the inside and you draw a circle to the operator that's closest, and then you do the next operator, and you sort of go around, right? Because the way they bind is it goes in a circle where it binds to the next operator that's closest. He would make us do lots of pointer arithmetic, so So that should still compile. And it's going to run and give us like funny numbers, right? No, they all ended up being 0. But right, because we didn't actually we didn't put anything into that array. So we could have filled the array, which is a pointer to an array of pointers, right? A pointer to an array of integers. My bad.
So if you have so we had a pointer within our structure, we had to allocate memory.
Yep.
Before. Alright.
Yeah,
So if you just make when you allocate for Bob, it doesn't automatically allocate for its members.
so it does allocate for its members, but remember. So an integer is 4 bytes, right?
Right.
Well, what's an integer pointer? 64-bit machine.
8.
8 bytes, right? So it's going to allocate 12 bytes, and y is going to point to some location. Now, for me to make it point to some valid location, I have to either allocate memory or already have something allocated. So for example, in your data structure, you don't need to allocate space for the pointer to next, because you're either setting it to null, or you're going to be inserting it in the list and you just make it point to the next thing. So it's already allocated. But if it's data that's not already allocated, then you have to actually allocate space for that. And we haven't really talked about it, but we also, and maybe we'll talk about this too. We also, when we're done with doing all of this, we don't really worry about this because our program like starts and then it quits, right? And we don't care how long it runs. But when you're actually doing this for operating systems, for programming languages, we're going to have to actually go back and free memory, right? So we're always allocating, but we also need to free. And when we free it, we need to free it in reverse order. So we would technically, if we're going to do free, which is give back the memory, we'd have to free Bob arrow Y before we free Bob. Because if we free Bob first, and then try to free Bob arrow Y, well, Bob arrow Y is already freed. And when you try and do that, those are bugs called use after free, which are useful when exploiting systems if you're a hacker, right? But hopefully we're not bad hackers. So yes, we have to allocate the space if it's a pointer to something. And in your data structure, right, you should just have a pointer to another structure, which should be fairly simple to code for that, right? Because you don't have to actually allocate the space in this example. Yes?
Yeah, can we go over like text processing? Because I'm having trouble like making sure they have the 3 periods and everything.
So, depends on how you want to do it.
Okay.
So what is your plan
I
on?
use ATOI, and then I use the string character like class, and it uses the period to delimit everything. And then it checks to see if the values are within 0 and 255. But I just don't know how to count and make sure they have 3.
So stir character, let me look it up. Stir char?
Yeah. STRCHR.
Oh. Stir char. There's another function that also returns a character pointer. Yeah, so there's a lot of ways to do it. So what this does is it's going to go through and find the... So you're wanting to count periods, right?
Yeah.
So a method of counting periods So if we run anybody want to guess what this is going to print? Oliver says this. So let's look at the man page. Searchar returns a pointer to the first occurrence of the character C in the string S.
So the address of
It's going to give us an address of a string. What string is that going to be?
this.
You say this. Any other guesses that are correct? Okay, so read it and think about it, right? Returns a pointer to the first occurrence of the character C in the string S. I think I forgot an argument, right? I need to put my argument in here. The character, of course, we're looking for is dot, right? Make it a character. So my string is this space dot space is space dot space a space test. All right, so these are all characters in a string. If I was very careful, I could draw little boxes around them all. Right. If I wrote better, it'd also help. Right, and then there's a null at the end. So what is the string that it's going to point to? It says it's going to return a pointer to the first occurrence. So my pointer to my string points there. So where is this pointer going to point? Forrest, you got a guess? You were pointing at the screen. Take a guess. To the dot. Right? Or I think it'll stop at the null, I believe. If I didn't read that in the doc, but I'm going to guess. Stir char null is the same, except it returns null if there's a null pointer at the end of S rather than null. So this should did I define need the brackets after, don't I? Of course. All right, so when I printed off dot, right, it printed dot is a test, right? So I know that, first of all, foo and dot were different, right? So it at least went through that. But if I take dot and I call it again, except instead of calling it on foo, I call it on dot plus 1. Right, why would I do plus 1? Skip past the dot that I already have, right? And I probably don't need to redeclare dot, but I should have put a new line. Trapped. Right, so now it started at the character after the dot. Right, so you can see that I can at least figure out. Right, and if you look at what A to I, it'll process all of the characters up to a digit, I believe, right?
Right.
So if I had a IP address, right, I'd have some characters. So you can use the stir char to figure out, is there another dot, right? So at least on the first one, you want to see if there's another dot, right? If there's not, bad stuff, right? Then you go on to the second, you do your stir char, or A to I, right? It will give you that number, right? And then you go ahead and find that dot and go +1, and then, right, do this process 2 more times.
Okay.
So at any point, right, you do the dot, and I think when it, let's do this out to its conclusion, right? Nope, let's do yank to yank. Let's see what it prints. I did a couple more times. All right, so we can see that it does return null. Right, so it actually doesn't point to the null character, it points to actual null. Right, so you know if you do this and it points to null, which is a check you should do, then they didn't enter enough dots. If you're assuming there's another dot, points to null, right, give up. Dr. Miller is a jerk, right? He typed crap into my program. Junk. My wife says I shouldn't use this word, so. Of course, our son uses the word poopy, so, you know, whatever. I get in trouble, but. Does that make sense?
Does. Also, I created 4 variables, like first, second, third, and fourth. Once it does that, it gets after the period, it assigns it to an integer, and I do that to check if it's between 0 and 255. Is there an easier way to do that?
Well, you could use your structure and do the A to I directly into your structure.
Okay.
So that'd be one way, but if you do variables, that's fine.
Okay.
I mean, it's not a big deal.
Since strtoke does not recognize white space, are you going to enter spaces?
It doesn't recognize spaces in the sense that.
Like, in a bunch of characters, like, if you go, like, 1 space, period, space, 1, like, it just won't recognize those as being null. Or as being, whatever, empty.
So will it just ignore them? Are you tokenizing on like dots?
Yeah.
So you're saying it
It just won't. Like, if you go period, 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 it won't recognize, like, a null in between the tokens.
well, you can detect that, right? You can detect that they're like entering garbage.
To a point.
Let's look.
Non-empty tokens.
So if no more tokens are found, it returns null. So when you call stir token and you got spaces, are you saying you get tokens back that are the empty string?
Not getting any token back from that, it'll skip it and go to the next one.
Okay, well, that's fine. So if I entered an IP address that was like 9 space space dot space space 9, you're saying that would work or not? If I did more of those.
I don't think so.
Okay, so you mean it doesn't work or it does work?
It does not work.
Does it give you an error?
No.
So it gives you the IP address.
No.
What does it give you? Zeros?
I'm not, like, printing out the token, so I couldn't see for
Oh,
sure,
okay.
but it just says that it's formatted incorrect.
You can show me. I can look at it.
Okay.
I mean, in general, right, you should be able to handle sort of anything that's bad. I think there might be where you could replace every space with nothing, right? So you could just like take your string and replace all white space with nothing, just to see if you can remove stuff that's at the beginning and the end. So that's one possibility.
I have 2 questions. The first one is about the string to function. When you use it the string, and you print the original string after you only print the first token. It's like, for example, your full example, if you use the string token function on this, and you print the original string, it's going to print only this.
So you're saying if I call hey, so you're saying if I print this, that
And if you print full after,
so it's modifying. So oh, I want to print food, right? Passing argument to
It has to be double quotes.
oh, it's a string. Oh, not a character.
Yeah.
My bad. I don't. Real programmers don't use stir token. No. I don't know. You guys should check out my door. I have a poster that is funny, but
Let's, you put C and not period.
oh. So I think let me try an experiment here.
I've read online and they say it put a new value after the first token.
Yeah. So I think if 0, 1, 2, 3, 4, 5. Oh. Yeah, so what it does is it, after the first call, right, it is changing a dot into a null. So the actual whole string is still there. It's just got a null in the location of that first call, right? So yeah, foo is going to point to something different, right? So if you need to keep the original, right, for some reason, you need to do like a stir copy. That's one way of doing it. Or just know that wherever the null is, the next thing after, right, is, and I think, right, you keep calling stir token, right, on foo, and it will go and, right, keep looking for the next dot that's in there. So yeah, you just got to kind of learn the idiosyncrasies of how stir token works if you're going to go ahead and use that. Or you can manually do the parsing and using index, and so there's a lot of different ways to do it. But.
So how to do it? There is a function called is digit to check if string input is an integer.
It'll check if it's a number, right? 0 through 9.
But when I use it, I can find it like error saying something.
Did
Give me
you-
a warning.
I think you probably have to make sure that.
I think it has to be of type integer.
So did you include ctype.h? Yeah, so make sure you include, you gotta include the right header if you don't, otherwise it gives you a warning saying, I think I know what you're talking about, but I could be wrong, right? So, yeah, just make sure you include the right headers. Other questions? Well, in light of the fact that there are lots of questions, and I like to be not the worst teacher in the world, I think I'll push back the due date to Friday so you guys can work on it more and ask more questions. That does not mean that you should sit on your duff until Friday morning and then ask many more questions, right? I'm giving you this extension so that way you guys can work on it, ask more questions, and come in.
Can you return a string? Or can you not? So,
Can you what?
can you return a string?
A char pointer? Yeah. Yeah, you can return a char pointer in C. Okay, so happy coding tonight. You don't have to stay up all night, but you should really work on it.
I'm allowed multiple submissions on Blackboard because there is mine and like
I can change it. I have to change the date anyway, so I'll change it so it'll do unlimited submissions, but I'm only going to grade the last one. That's my rule. So.